Your dog's brain lights up when it smells you. Not food, not another dog. You. The specific chemical signature of your body activates the reward center of your dog's brain more powerfully than anything else in its environment. And your dog has never once thought of you as its owner, or its master, or its pack leader. It has a completely different category for you. One that took neuroscientists years to confirm, and one that changes what you think you are when you walk through the world. Because every animal you've ever stood next to has a theory about what you are. Not one of those theories matches what you think. For decades, the dominant story about humans and animals was built on hierarchy. You are the master, the trainer, the alpha, the keeper. Animals respond to you because you hold power over their food, their shelter, their safety. That was the model. It felt logical because it centered you in a role you recognized. Then, in 2012, a neuroscientist at Emory University named Gregory Berns did something no one had done before. He trained dogs to lie still inside an fMRI machine while fully awake, and he scanned their brains. The results were published in a paper titled Functional MRI in Awake Unrestrained Dogs, co-authored with Andrew Brooks and Mark Spivak in the journal PLOS. What Berns found didn't just challenge the hierarchy model, it replaced it with something stranger, more specific, and more personal. The question the research actually answers isn't, do animals understand us? The question is, what do they understand us to be? The answer is different for every species, and once you know it, you cannot unknow it, because it changes what you are the next time you step outside. In Berns's lab, dogs were presented with 5 scents: their owner, a familiar human who wasn't their owner, an unfamiliar human, a familiar dog, and an unfamiliar dog. The caudate nucleus, the brain region most associated with reward, anticipation, and positive emotion, activated significantly for all social scents. But it activated most strongly, most consistently for one, the owner's scent. Not the other dog, not the familiar human, the owner. Berns's conclusion was precise. Dogs don't see you as an authority figure. They don't see you as a resource dispenser. The neural evidence suggests they have placed you in a category typically reserved for close family members, the category of most rewarding presence in my environment. You are not their boss. You are, in the clearest neurological sense the data can offer, their favorite. Think about that for a second. Every time your dog ran to the door when you came home, that wasn't performance. That wasn't conditioning in the simple sense. That was a brain-wide reward response, measurable, specific, directed at you. Not at food, at you. But your dog's theory of you is only one theory. Because your cat has been running a completely different one this whole time. And it says something much stranger about what you actually are. That theory runs deeper than you'd expect. In 2013, anthrozoologist John Bradshaw at the University of Bristol published Cat Sense, and inside it was a finding that remains quietly unsettling. Dogs, it turns out, have developed 2 distinct behavioral repertoires, one for other dogs, one for humans. They've adapted across thousands of years of domestication. Cats have not. Cats use the exact same social behaviors with you that they use with other cats. The tail-up greeting, the slow blink, the head rub, the kneading. Every one of those gestures is drawn from feline to feline communication. Bradshaw's conclusion: cats do not appear to recognize humans as a fundamentally different kind of being. They treat you as another cat, a large one, a clumsy one, a socially confusing one who does everything slightly wrong and never quite learns, but a cat nonetheless. What Bradshaw describes is a social species applying its existing behavioral toolkit to a novel social partner rather than developing new categories. For cats, you are close enough to a cat that the existing toolkit applies. When your cat slow blinks at you, it is not doing something special for humans. It is using its deepest trust signal, the one it was born with, the one it would give another cat it had decided was safe, and it is giving it to you, because you qualified. That's not a small thing, but it's not the strangest part. The strangest part involves the animals who don't live with you at all, the ones watching from outside, who have already made up their minds about you. In 2006, John Marsluff at the University of Washington began an experiment in which researchers wore specific rubber masks while trapping and banding crows on campus. The crows became alarmed. What wasn't predictable was what happened afterward. Marsluff tracked the crows' responses to those masks across follow-up studies spanning years and published the core findings in 2010 in the Proceedings of the National Academy of Sciences. The crows not only remembered the threatening face, they were still scolding and dive-bombing people wearing that mask 5 years later. Not the same crows who were originally trapped. Their offspring, their flockmates. Crows who had never encountered the original trapping event had learned the specific face of the threat from other crows who had. The crows on your street have a file on you. They assembled that file from direct observation and from social transmission, the way information moves through a community. They know your face. They know whether you've been neutral, threatening, or generous. And they have shared that assessment with birds who've never met you. Crows are not simply reactive. They maintain a long-term social record of individual humans they have never personally encountered, passed down through behavioral teaching. That's something we tend to assume only humans do. In 2016, Amy Smith at the University of Sussex published findings in the journal Biology Letters showing that horses distinguish between angry and happy human facial expressions with measurable physiological precision. An angry human face triggered elevated heart rate in the horses and a left gaze bias. The left eye connects to the brain's right hemisphere, which in mammals processes threatening stimuli. The horses weren't just seeing a face. They were reading an emotional state in real time on a human they may have just met and adjusting their internal stress response accordingly. A stranger's mood, written in muscle and skin, was legible to them on first glance. You have never been unread in the presence of a horse, and none of that prepares you for what the wildlife data reveals. Because there, the theory every wild animal holds about you is something far more extreme. Your dog's caudate nucleus fires for you the way it fires for nothing else on Earth. Your cat has filed you under large, trusted cat, and acts accordingly, using the same slow blink it would give its most trusted companion. The crows on the block where you live have noted your face, conferred with their flock about it, and reached a verdict. The horse you stood next to at a fair or a field had already read your expression before you finished forming it. You move through the world thinking you're a neutral presence, a background figure you're not. In 2023, Liana Zanet at Western University published a study in Conservation Letters in which recordings of human voices, lion calls, dog barks, and gunshots were played to wildlife across multiple continents and ecosystems. 95% of species tested showed stronger fear responses to a human voice than to any other sound. More than lions, more than dogs, more than gunshots. Deer, birds, primates. The stress response triggered by a human voice exceeded the stress response to their actual natural predators. Every species tested. 95%. To the wild animal you passed on a hiking trail or that froze in your headlights on a country road, you are not ordinary. You are the apex predator of the planet. Not lions, not wolves. You. Your voice alone is more frightening to most living animals on Earth than the sound of a lion calling. You are, at the same time, the safest thing in your dog's world and the most dangerous thing in every wild animal's world. Both of those are true. Both of those are you, and you carry both of those identities simultaneously every time you walk out the door, whether you're thinking about it or not. Both of those are you. And the honest answer is that science can tell us the measurements behind each of them, but not what those measurements feel like from the inside. The fMRI data tells us which brain regions activate. It doesn't tell us what a dog experiences when that activation happens. The behavioral data from crows tells us they maintain and transmit information about individual humans. It doesn't tell us whether there is something it is like to be a crow, recognizing your face across a street it has learned to associate with you. The horse's heart rates rise at your angry expression. Whether that rise is accompanied by anything resembling fear in the way you experience fear, the data cannot reach that. What the data cannot reach is the interior, We have the neural correlates, the behavioral signatures, the physiological measurements. We have everything science can currently build an instrument to record. What we don't have is access to the experience those measurements describe, the felt quality of what happens when your dog's reward system fires at the smell of you, or when a crow that has never seen you holds a learned impression of your face. And so the question that remains genuinely open, that the data raises and cannot answer, is this. When your dog's brain fires its deepest reward response at the smell of you, is there something it is like to love you? Or is that just our word for their data? Your dog's brain lit up for you, not for food, not for another dog, for the specific chemical trace your body leaves in the air. You thought you were ordinary. Nothing with eyes has ever seen you that way.